This problem is from chapter 23, number 5, automobile and battery. It says the total charge that an automobile battery can supply without being recharged is given in terms of ampere hours. A typical 12-volt battery has a rating of 60 ampere hours, 60 amps for 1 hour, 30 amps for 2 hours, and so on. Suppose that you forget to turn the headlights off in your parked automobile. If each of the two headlights draws 3 amps, how long will it be before your battery is dead? Okay, first of all, we have to decide here what kind of circuit do we have. Do we have a series circuit or do we have a parallel circuit? So I forgot. Okay, so here let's draw a series circuit. Takes a little bit. And this was supposed to be my battery right here. And then I'm going to draw a lamp in here and a lamp in there and fix the connections here a little bit. Okay, well, what if one of them actually goes out like this one here? Well, in that case, I actually have a gap in there, pretty good gap, and I have no electric circuit anymore, closed electric circuit anymore, and the second headlight over here will also go off. So by default, the circuit for the two headlights would have to be in parallel. Here is the battery, and here are the two headlights. There's one, and there's one, and here's a connection. There we go. So I have a closed circuit here, two headlights in parallel, and if one of them goes out, such as this one, then for the other one, the circuit is still closed and it will keep shining. And that, of course, is the way our car headlights are operating, that if one goes out, we still have the other one available. And if we drive at night and continue doing that, sooner or later we will be pulled over. Anyway, I checked out circuits on the internet to come up with an example, and here is one. And here's the positive, that's from the battery, and that's indicated by a red wire. Notice there's nothing on the negative, but that's because it's connected to ground, just as all the other appliances here, such as the headlights or the high beam indicator or the dimmer over here. In the schematic, the negative actually should be connected to ground as well. Anyway, there's a wire going here through what is called a starter solenoid. That means this one here has to get started first for any of the headlights to be turned on. So that means that for this kind of schematic, if your car is actually not running, the headlights are not going to turn on. So you're actually safe against what the problem actually says. But in some older cars, and some are still manufactured, you could actually accidentally leave the headlights on. In any case, here goes the current, and then it goes in here and in here, and of course it has to be connected. Well, that's where the dimmer comes in. So I guess this is the low beam, and then this here is the high beam. So let's look at the, this one here. This one here is the low beam, and this one is the high beam. That's just where the current comes in. And this is the headlight switch, which then tells the dimmer which mode to be in. And let's just look at the low beam, where then the current from the other direction flows this way here and going in there. And then this one here is connected to that one over there, and current is flowing in there and going back to the ground. And over here for the other one, current is flowing in here into the headlamp and to the ground. And the dimmer here, this one here, basically tells the relay to do this here, or the other one, the high beam, tells the other relay to do this here and connect and make it a high beam. But notice that if something here is broken on one of the headlights, then the other one is still functioning because the current can run through the headlight. I found another one which is really pretty, I would say. This tells you the entire electronics and electrical wiring inside a car. We can obviously see the headlights here. Here's the battery. All these little orange things here, they mean grounded. That's what I said earlier about the negative of the battery. And then if we followed here from the headlamps all the way around here, I didn't get into detail. When I looked at this one here, we could figure out that they're indeed wired in parallel. Okay, anyway, that was a long story to figure out that our headlights need to be in parallel, which means, yeah, this one here is not going to work. Okay, now it says in the problem that we have a typical 12-volt battery, so V equals 12 volts, and that the battery has a rating of 60 ampere hours. So at most, this is how it can use up. By the way, the unit for that would be in coulombs, pretty large, so it would be actually a charge. So the charge of the entire charge of the battery would be this one here, expressed in amp hours. Makes it a little bit easier for the calculation than coulombs itself. And then it says, suppose that you forget to turn the headlights off. If each of the two headlights draws 3 amps, how long will it be before your battery is dead? So for each of them, we have 3 amps going through here. 3 amps going through here. And of course, with the junction rule, oh, notice that I drew this in the opposite way. Whoops. Didn't pay attention here. Because my positive terminal is over here, the current should go in this way. There we go. As far as the problem is concerned, that's no biggie. What a little mistake that I just made, but I want to do it proper anyway. Okay, so 3 amps going through each one. According to Kirchhoff's rule, with this one here being a junction, the current that splits up right here and then comes back together at the other junction is the total current of the entire circuit. So I have 3 amps flowing through here and 3 amps flowing for this one, which means that the total amount of current that goes in here must be 6 amps. And of course, as written earlier on, the battery itself is 12 volts. Okay, at this point there's actually a quick way of doing this, and that is to say, okay, I know what the rating is, 60 amp hours, and I know what the current is, 6 amps, and if I put these two together, amps and amps, they may divide, and I'm left with hours, and that's exactly what they're asking for. How long will it be before your battery is dead? So I'm just going to put this together here without actually drawing on any one equation from the book, but this should make sense. And then I would have charge divided by current, 60 amp hours divided by 6 amps, which is 10, the amps divide, and I'm left with hours, which means that charge divided by current is time, and the answer is that it takes 10 hours for the battery to drain. As I said, this one is the quick way. Here is the proper way, and for that I would, as I said, this one here is, oops, I'm sorry, this equation here I just came up with because it made sense, but there is a proper way of doing it with looking at equations that we have encountered before. One of them would be the amount of work that any kind of appliance can do, which is work is power times time. That is from quite a chapter, quite a few chapters ago. And then power is, as we encountered in this or the previous chapter, is electric current times voltage, and that is power times the time that is already over here. And then plug in the numbers. Well, actually, hold on. Before I plug in the numbers, let me just turn a couple of things around, which is volts times current times time. And notice that this last one here is amps times hours, which is given for the battery as 60 amp hours. And of course the voltage of the battery is 12 volts. And then 12 times 60 is 720. Which kind of unit? Well, this one is going to be volt amp hours. However, I should convert that to volt amp second. And in volt amp second, that would be the basic unit for work, standard unit, which means that is actually the joules. So I'm going to take this number here and convert it hours to seconds, which is times 3,600, which is 2,600,000 joules, or 2.6 million megajoules. And now I'm going to say, well, what's the time then it will use to drain at 6 amps? Well, I'm going to do time using this equation here, and of course that is work, the amount of work that the battery could deliver divided by the current and the voltage, and that would be then 2,600,000 joules divided by the current of 6 amps and the voltage of 12 volts. And when I calculate that out, I come up with 36,000 seconds. By the way, my 2,600,000 joules earlier was a rounded number, so the 36,000 here again is rounded. And that one then is 10 hours because there are 3,600 seconds in the hours. Of course, that's the result I had earlier. Notice that my second calculation is a whole lot longer than the first, but I did that in order to show the proper way and the shortcut that I just discovered by looking at the numbers. So either way of them, either one of these two works.